Question 2 says a gun of mass 8 kilograms fires a bullet with a mass of 25 grams. So immediately when we read this, we just need to be a bit careful. So 25 grams, we can write as 25 times 10 to the minus 3 kilograms at a velocity of 320 meters per second. Calculate the recoil velocity of the gun. So once again, I think it's helpful to draw a before and after picture. So initially we have the 8 kilogram gun, the bullet, I'm just going to label its mass as M because I can't be bothered to write out the standard form, and everything is stationary. And then afterwards we've got the gun, which is going to be traveling at this direction with a velocity v, and we've got the bullet, let's do it in a different color, which has still got mass m, same as this number written at the top, traveling at 320 meters per second. We know that the momentum before is equal to the momentum after, but the momentum before we don't need to do any calculating for. We can see is 0 Newton seconds or kilogram meters per second. So the momentum after should also be equal to 0. So we can write 0 is equal to, let's write the positive term first. So the mass of the bullet, that's 25 times 10 to the minus 3 times 320. So mass times velocity. Plus we've got the momentum of the gun. So that's 8 times, and since I've labeled this going to the left, I'm going to call it minus v. I think v would be, my labeling is complicated. Really, I should have drawn it this way, and then I can use it as a minus v. Let's not worry about it too much. So v should be equal to 25 times 10 to the minus 3 times 320 over 8. Which is 1, everything's to 2 significant figures, so 1.0 meters per second. Calculate the minimum energy of the explosive used in this cannon. So in this question, there's been an energy change. At the moment, there was what we might describe as a chemical energy store in explosive. And during the launching, this chemical energy store has got converted primarily into kinetic energy in both the gun and the bullet. There's probably also some sound, some thermal, perhaps some light energy that comes out of this. We don't know about these though, which is why the question says minimum in. So we can work out how much energy has gone into the kinetic energy. So what this question is really asking us is what's the kinetic energy after the explosion has happened. So we can say that the kinetic energy is half mv squared for the gun plus half mv squared for the bullet. So this should be equal to a half times 8 times the speed of the gun squared, which is 2, plus a half times 25 times 10 to the minus 3 times 320 squared for the bullet. So the first bit we can see is 4, that's easy enough. And the second thing is 1,280. So the 4 isn't going to matter if we only write this to 2 significant figures, so 1,300 joules.